Okay, so today we're going to talk about, we're actually going backwards, back to section 3, which is dividing polynomials. So if you think back to section 4.2 and what we did on our quiz from 4.2, we can add polynomials, subtract polynomials. Both of those are just combining like terms. And we can multiply polynomials doing distribution. So the one thing we have left to do is divide polynomials. And so that's what we're going to look at today. Now, what's really cool at the beginning of today, we're going to take a trip down memory lane back to probably 4th grade when you first learned long division. So I'm going to start you off with a very easy problem. 17 divided by 3. Who remembers their 4th grade teacher? A guy, who is your 1st grade teacher? Miss who? Staggy? Oh, was she nice? Ish. Okay, good. Faith, who is your 4th grade teacher? Miss who? Ryman? Was she nice? Okay. Anybody else remember their 4th grade teacher? Oh, Bailey, who's your 4th grade teacher?
Miss Nelson.
Miss Nelson, was she nice? Kylie? Mr. Matthew, was he nice? Jace? Mr. Matthews, you guys were in the same 4th grade class? Oh, wow, grade school buddies. You've known each other that long. Cool. And you thought he was nice too? Seems like all 4th grade teachers are nice, right? My 4th grade teacher was nice. Her name was Mrs. Foltz. I remember her. You always remember your elementary school teachers, right? Okay. Okay, so go back to your 4th grade teacher. What did she tell you about division? So when you set up long division, you make that long division box, right? Which number goes inside the box? The 17, okay? This number that you're dividing is called the dividend. The number that you divide is the dividend. So the number inside the division box is the dividend. And what number goes outside the division box? 3. Does anybody remember what 3 is called in division problems? It's the thing you're dividing by. It's the divisor. So the thing you divide by is called a divisor. They all have names, all these parts. Okay, and so you start long division. And one way to start long division is like you might think about 3 and you say, can I get 3 to go into 1? No, too big. So can I get 3 to go into 17? Yeah, how many times does 3 fit into 17? 5 times. Okay. So you put a 5 on top. Okay. And in long division, it was really important if you were dividing 3 into 17, you would put the 5 above the 7, right? That it mattered like which number you put it above. That's going to matter for us when we do polynomials in a little bit too. We're going to have to be really organized. What do you do with that 5 at the top? Multiply it by the divisor, which is 3. Thanks, Sierra. So we're going to do 5 times 3. I'm going to write my work off to the side right here. 5 times 3 is 15. And then what do you do next? Subtract. And then 17 minus 15 is 2. Does anybody remember what 2 is called? It's your remainder. And then the part above where you divided, that's your quotient. Okay, so you got a remainder and you got a quotient. Okay, now this is where you got to go, way back to 4th grade. What was the very first thing you learned to do with your remainder? What do you mean leave it?
Like, wouldn't you just, like, make it a fraction?
Fraction is one thing we will do, and we're going to look at that piece. Did anybody do anything before they started making fractions? Okay, you could add a 0 and a decimal, right? Were you going to say something else? Anybody remember anything else you did with that remainder? Way easier than fractions and decimals. You put it up top somewhere. Did anybody ever write their answers 5R2? You ever remember seeing that? Oh, those were the good old days, weren't they? When you could just write your answer like this. 5, remainder 2. Oh, those were the good days. And then we graduated. We put a decimal there and a 0, and then we said how many. We dropped the 0 down. We say how many times can 3 go into 20. So we did those types of things. And I like the other idea of the fraction piece. How did you make a fraction with that remainder of 2? What was your final answer when you made it into a fraction? You got a quotient 5, you got a remainder 2. What's your answer with a fraction? 5 and 2 thirds. You put it over your divisor, don't you? Okay. We're going to kind of take this idea. We're going to take the whole division idea. We're going to take that fraction idea from our numerical long division, and we're going to apply it to our polynomial long division. I guess I'm wondering, would you be okay with me saying as 5 and 2/3 is the same as, same as 5 plus 2/3? Do you think that's true? 5 and 2/3 is the same as 5 plus 2/3? One way you could check to see if that's true is like think about them as improper fractions, right? So like this one, do you remember changing into an improper fraction? 3 times 5 plus 2 is 17/3, and that was our original division problem. And then if I were doing this, this is like 5/1, 2/3, so I need common denominators. And I multiply this by 3/3, so I'd have 15/3 plus 2/3, which that will be 17/3. So are they the same thing? Yeah, they're both equal to 17/3. Okay, so we're going to kind of steal this idea with the fraction, but we're going to need to put a plus sign in between because we're working with polynomials, so we need different terms. So we're going to say it's plus that. Okay, so here's our first polynomial long division problem we're going to do. We're going to do the same process that you learned back in 4th grade with polynomials. X squared plus 7x minus 2 divided by x minus 2. You have all the same parts of a division problem. You've got a dividend, and you've got a divisor. You put them in the same places. The dividend goes inside your long division box. The divisor goes outside your long division box. So let's write this out like long division. X squared plus 7x minus 2 and x minus 2. Now I'll mention this, it's not really a worry to us right now because we have everything I need. But inside the long division box, you want to make sure like your polynomial is written in standard form, so the highest exponent comes first. And then you want to go in descending order, and you always want to make sure you have every term after the highest exponent. So if I'm working with an x squared, which is quadratic, I want to have an x squared term, I want to have an x term, and I want to have a number term. If I'm missing any one of those, I'll put a 0 there. And we'll do an example, hopefully, that will show us what to do when that happens. Okay, but you need a placeholder. Okay, so we're going to start dividing, long division. And do you remember how, like, let's say I add some extra numbers to this problem, 17 divided by 3, and I call it 17,528 divided by 3. Did you start worrying about how many times 3 went into that whole big number, 17,528? No, you worked it just the way we did with 17, right? How many times can I get 3 to 17? I'll worry about the other numbers later. The same thing is true with polynomials. I'm not going to worry about every single term, because I can't. I'll only worry about the first term. So I'm going to color code this. The first term of my dividend is x squared. The first term of my divisor is x. I'm only going to worry about those two terms. Okay. And I'm thinking about how many times can I get x to go into x squared? But a better question is, what can I multiply x by so that it is x squared? X. So that's going to be the number that I put in my quotient. Now, in polynomial long division, you want to line everything up with its like terms. Since we're going to multiply by x, we're going to put it above the 7x. So we're thinking, what do I multiply that x in the divisor by to get the x squared in the dividend? And you guys told me x, so we put that up in the quotient. What do we do with that thing we put in the quotient? Next step to division? Multiply. So we're going to take, and I'm going to do my work just like I did 5 times 3 over here. I'm going to do x times x minus 2. So when I multiply x times x minus 2, I'm going to get x squared minus 2x. You okay with that? You got to distribute to both parts of the divisor. Now, what do you normally do after you multiply? Subtract. And this is where you have to be very careful. This is where you got to think real hard and be a really good, studious Algebra 2 student. We want to subtract, usually we just subtract the number 15. There's only one number there, right? Now we're subtracting things that might have multiple terms. So we really want to subtract all of x squared minus 2x. To say all of something in mathematics, you use a group of parentheses. Okay, so we want to subtract all of it. I don't want to just subtract x squared. I also want to subtract a negative 2x. Skylar.
Why would you get negative 2x in the other thing?
How do I get negative 2x?
I don't really understand what you did.
I took x times the divisor x minus 2, which is right over here. This is my work. This is not actual part of the division problem. But then x times x is x squared. And x times negative 2 is negative 2x. So you have to distribute it. That's
Why'd you put the x on top of the numbers?
because, see, look how this is. I can line up only x squareds in this first column. I can line up only x's. And I can line up only numbers. So in polynomial division, you have to be really organized. Does that answer your question? Okay. Now, if I'm subtracting all of that, I can distribute my negative. So I'm going to use my red marker to add the opposite. Okay, I'm going to change this subtraction to a plus sign. And then these two will change signs. The positive x squared will become negative x squared, and the negative 2x will become positive. You guys told me I should subtract in division, and I'm just going to add the opposite, because then I won't forget to subtract the second term. Okay? Now, I've changed it to addition, so just add down. What's x squared plus negative x squared? 0 cancels out. And what's 7x plus 2x? 9x. People who don't practice and people who don't check their work on a quiz or a test are going to tell me that's 5x. Because they're not going to practice distributing their negative. They're never going to check to see that they're getting right answers. And they're going to forget that really important piece. So if you're thinking about 5x, you're doing it wrong. gotta subtract negative 2x, which is really adding it. What would you do after that when you get that 9x? Bring down the 2, the negative 2, right? So you drop what's left over, and you start the whole process over again, right? What do I have to multiply by to get this number? Or how many times can I get this number into this? Again, can you worry about everything? No. You can only worry about the first terms. So I can only worry about the x in the divisor and the 9x in my division problem. That minus 2, I just I ignore it when I'm deciding what's going to go in my quotient. So what do you have to multiply x by to be 9x? 9. And then I'm going to do my work off to the side, where I take that 9 times the divisor x minus 2, which would give me 9x minus 18. Think real carefully about that. Nice 4th grade teacher, what they told you to do. They told you to subtract next. And we really want to subtract the whole thing, so we're going to put it in a group of parentheses. And then we're going to distribute our negative. We're going to change the signs of both those terms because they're really getting subtracted. So we're going to add the opposite. Plus a negative 9x and a positive 18. The 9x plus negative 9x will cancel, and a negative 2 plus 18 will be positive, because the bigger number is positive. You're at the end of the problem, right? There's nothing left in the quotient. You're at the back of the quotient. You got the number term lined up. So 16 must be your remainder. And we're going to do like we did. We're going to take our remainder and put it over our divisor, but we need to put a plus sign in between the last term and that remainder over divisor. So we're going to say for our final answer, we'll have plus 16 over x minus 2. And that's my polynomial division. I'm going to give you one to try. Can you divide x squared plus 13x plus 40 by x plus 5 for me, please? So set it up first, and then think very carefully about the process of long division. Everything about long division that you know from elementary school is still the same. And you can only worry about the first term. Talk to your shoulder buddies too if you need to. What'd you do?
You were right.
Oh, I meant talk to your shoulder buddy and ask them if you're having trouble. I was. Yep. Good. Okay, so you're really subtracting all of that. Can you put that in parentheses? Your x squared minus 5, not the negative. Okay, so it's minus x squared, and it's minus 5x. So I change it to plus, minus, minus. You can always change the subtraction to adding the opposite. And that will prevent people from forgetting to subtract the second term. Worry about the first terms only, x and x squared. What do you have to multiply by? What's the distribute chance to be? Your x plus 5. Worry about the first terms only, x and x squared. What do you have to multiply x by to make it squared? So then on this one, above the x, put an x up there. And then multiply it by your divisor, just like we used to do. Yeah. Well, so, yes, you will. Yes, it will work out nicely. You're not gonna scare. Ooh. So when you say minus all of it, you got a plus. And then change the signs of both of these. This is now a negative, and this is now a. So 13x plus negative 5x. You gotta be real careful with that. Okay, now distribute. Multiply it and put them underneath. Good job. Yep. 8 times 5. Well, you put an 8 right there, and then you're doing the old problem. So you gotta be careful. Good work. You guys are doing a great job. Put the dividend inside. Put the divisor outside. Worry about the first term, x and x squared. We gotta multiply by x. Distribute it, so x times x is x squared, x times 5 is 5x. And then subtract all of that. So I'm going to change it to plus, and then it'll be a negative and a negative. And when I add down, I'll get 8x plus 40. And then I must multiply by 8. Okay? So that I get 8x with my divisor, so put plus 8. Now what's really nice about this one? What happens when you subtract? You get 0. Zeros make me happy at the end, so I put smiley faces inside of them. That's how happy they make me. That will be important later on. Yes. You'll be looking for those smiley faces. Okay? Good work. Okay, now, that's long division. I'm going to teach you synthetic division. I need everyone to be like awake and alert, because synthetic is just a list of steps. It takes all the meaning for us out of the division, and we just run through the steps and we get the same answer.
Would you leave it like that, or would you add?
You can add 0 over x plus 5, but 0 divided by anything is 0. So I would just write my answer as x plus 8. Okay. So here we're going to do synthetic division. It's the same problem as before, right? X squared plus 7x minus 2 divided by x minus 2. I want to show this to you because we should get the same answer that we got on the first example we did. What did we get for that one? X plus 9 plus 16 over x minus 2. So this should be our answer, but we're going to do it a different way. Okay, to create synthetic, I want you to have like an extra line that you can write on, so space, and then I need you to make a box that's 2 lines big. So you're going to have 3 lines in a row. Okay, leave a line of space, and then a box. Like that. It's kind of like an upside down division. Okay. The top row of the box is for the coefficients of the dividend. Now, the dividend is the thing that you're dividing. Go to your dividend. What's the degree of your dividend? What's the highest exponent? 2. So above my synthetic box, I always write x squared, my highest degree, and then I write all the terms that should come behind it. Don't leave any term out. If you have x squared, you should have x, you should have a number. Okay? So I'm going to write those above it. If I started with an x to the 5th, I would write x to the 5th, x to the 4th, x cubed, x squared, x, and a number. I write so that I have all of them. Okay? Because if a term is missing, I need to put in a 0 coefficient. That is very important. Include zeros for missing terms. Okay? Do I have any missing terms in this example? No, so not a big problem. Okay? Drop in your coefficients. Coefficients only, so numbers. What's the coefficient to x squared? What's the coefficient to x? And the number term. Okay. Numbers only go in the synthetic box. Riley, are you paying attention? Synthetic happens very fast. You blink and then it's done. Outside of the synthetic box, we need to put sort of like our divisor, what we're dividing by, but we don't want to put an x out there, so we don't want to write x minus 2. Take your x minus 2, set it equal to 0, and solve for x. So what should x be on the outside? X equals 2. If I have x minus 2, then put a positive 2. Okay, if it looked like divide by x plus 2, it would be a negative 2. So it always looks like the opposite. Okay. Now, for synthetic division, you have 2 rules. Add down. And multiply. I call it like a little mantra. You just keep saying it to yourself till it's all over. Add down and multiply, add down and multiply, add down and multiply. Add down and multiply. As many times as you need to. The second line of your synthetic box will be answers to multiply. And the last line of the synthetic box will be answers to add down. So all your add downs go outside the box. All your multiplies go inside the box. You always go in the order of add down first, then multiply. So on the first add down, there's nothing to add. You'll always take your leading coefficient and drop it. There is no multiply because we haven't started yet. So we drop it, we add down, our answer goes outside the box. Okay. Now multiply. 1 times 2 is 2, and the answers go on the second line of the synthetic box. So on the next column, under the 7. So I added down to get 1, I multiply 1 times 2 is 2, and now I repeat, add down. 7 plus 2 is 9. Multiply. 9 times 2 is 18. Add down to get 16. Do the numbers at the bottom look familiar? Jace's answer from example 1. So So what happens in synthetic is you took an x squared, you divided it by x, so now everything on the line at the bottom is 1 less than it was before. This is now x. X's become numbers, and numbers become remainders. We had taken all the x's out of the problem, so now we put the x's back into the problem. Those will just be the coefficients to the terms. So when I write my answer, it's 1x plus 9 plus 16 all over x minus 2. Did we get the same answer? Yeah. Now, that one was not quick because we had never done synthetic before. But in the future, synthetic will be a faster division than the long division is. Okay. Does anybody have any questions about how I got any of my numbers? Yes, Jace. Oh, so, like, this is an x term, this is a number term, this is my remainder, and remember, your remainders always go over your divisor. So it's from my divisor, x minus 2. And that will change from different problems. Like on the problem that we did with the x squared plus 13x plus 40, you'd put 0 over x plus 5, because that's what we were dividing by. Okay. I wouldn't even include that, though. I'd just write x plus 8 if I got a 0. Okay. Okay, we're running a little long time, so I'm going to give you time to get the assignment down. There are 10 questions. 2 of them, I think number 5 and number 6 on page 177, are going to ask you to do long division. So I want you to try that out. Remember, all the rules to division are the same as they've always been. And then 13, 14, I think 27 and 33 will be synthetic division. And we'll go over many more examples tomorrow. So tomorrow will be day 2 of division. I am videoing this, so I'll post the video online if you need to watch synthetic one more time. Okay, that will be available for you online tonight.